Removal of an LT-5 engine from a ZR-1 Corvette does not require removal of the vehicle's hood assembly. For the purposes of this video presentation, the hood has been removed. You also may want to take off the hood to prevent damaging the assembly and to simplify access to the engine. As with any engine removal procedure, the first step is to disconnect the negative battery cable. Prepare to disengage the transmission. Remove the console trim plate and the accessory trim plate. Disassemble the shift lever assembly and remove the center console trim plate. Check carefully to be certain that all fasteners have been removed. Drain the coolant and engine oil. Next, the exhaust system must be removed. Begin unfastening the bolts at the rear, leaving the spring hangers in place. On 1992 and newer models equipped with two-piece exhaust manifolds, disconnect the catalytic converter assemblies. Now you can remove the propeller shaft. Support the transmission. Remove the driveline support fasteners and move the support aside. Adjusting the height of the transmission eases removal of the support bolts. Mark the relationship of the propeller shaft to the pinion yoke. The next step is to disconnect the rear universal joint. This is accomplished by removing the propeller shaft retainers. With the transmission in neutral, you can rotate the rear tire to turn the propeller shaft and rotate the retainers toward you. Tape the bearing cups to the trunnion to prevent the roller bearings from falling out. Slide the slip yoke from the transmission and remove the propeller shaft. Plug the transmission case extension to prevent spilling the oil. With the propeller shaft out of the way, you can complete the removal of the driveline support. Disconnect the electrical connectors from the speed sensor, the backup lamp switch, and the shift solenoid. Remove the transmission to clutch housing bolts. Then carefully disengage the transmission from the engine, taking care not to allow the engine to rock backward and damage the cowl. Remove the clutch actuator cylinder. Support the cylinder so that it does not hang from the hydraulic line. Next, remove the left side converter shield from the bell housing. Disengage the clutch fork. There is a clutch housing cover which must be removed. In order to install the rear engine lift hook, the bell housing must be removed. Unfastening all of the heat shields near the catalytic converter will make removal of the bell housing easier. Now the rear engine lift hook can be installed. Remove the AIR tube center section from the AIR hose and oil pan. Both O2 sensors must be removed from models equipped with one-piece catalytic converter exhaust manifold assemblies. On models equipped with two-piece assemblies, the O2 sensors can remain in place. Loosen both nuts retaining the engine mounts to the chassis, then lower the car. Remove the harness connectors from the ECM and remove the ECM. Notice how it slides off the mounting bracket. With the left front fender removed, remove the battery. Remove the windshield wiper cover and remove the map sensor and the bracket. This will increase clearance and prevent damaging the units when the engine is removed or reinstalled into the car. Disconnect all of the vacuum hoses and the wiring harness electrical connectors to the engine. Using suitable equipment, capture the air conditioning refrigerant. Now, disconnect the suction and discharge lines from the compressor. Disconnect the throttle cables. Next, remove the coolant outlet pipe assembly. Disconnect the engine oil cooler lines from the oil filter housing. To accomplish this, place a 1 1/4 inch wrench on the nut and strike the wrench with a mallet. This should loosen the nut without loosening the male adapter on the filter housing. If it is necessary to tighten the male adapter, take care not to over-tighten it, which could crack the housing. With the fuel tank filler cap loosened, release fuel pressure in the system at the fuel rail. Once this has been accomplished, disconnect the fuel lines from the fuel rail. Install the front engine lift hook to the front of the engine. Disconnect the evaporator housing panel and the resistor. Now unfasten the air conditioner accumulator and move it aside. Unfasten the bolts retaining the right bulkhead wiring harness connector. Remove the bulkhead wiring harness connectors from under the dash. One bolt holds the connector in place. Once the bolt has been removed, push the cover to the left to unlock it from its positioning tab. Disconnect the right side wiring harness. At the passenger footwell, disconnect the instrument panel right lower sound insulator panel. Disconnect the wiring harness connectors from under the dash. Raise the engine about 6 inches. This will allow easier access to the coolant pump inlet hose. Now disconnect the power steering pump lines and cap them to prevent contamination or loss of fluid. Finally, disconnect the power steering cooler lines. Visually inspect the engine to make certain that all connections have been disengaged. Carefully raise the engine from the car. On engines equipped with a one-piece exhaust manifold catalytic converter assembly, the engine must be tilted upward at an extreme angle. This is necessary to provide sufficient clearance for the assembly as it is raised from the vehicle. Take special care to prevent damaging the windshield or body while lifting the engine.
End Part 7. You should now prepare to take the next part of the test for this course. If you are unsure of the answer, you may stop the tape to think about the question, review the course book, or rewind the tape and review it before answering. Test Part 7. Start this part of the test at line number 21. Question number 21. When removing an LT-5 engine equipped with one-piece exhaust manifold catalytic converter assemblies, A, the manifold converter assemblies must be removed. B, both oxygen sensors must be removed. C, the drive shaft support beam can remain in place. Or D, all of the above. Question number 22. Removing a steering pump line from an LT-5 engine in a ZR-1, A, requires removal of the oil pump housing. B, requires removal of the plenum. C, is easier with the engine raised 6 inches. Or D, is easier from below the car. Question number 23. When removing an LT-5 from a ZR-1 Corvette, the air conditioning refrigerant should A, not be removed. B, be discharged. C, not be reused. Or D, be captured for recycling.
The LT-5 cylinder case is made of cast aluminum. The upper casing houses the cylinder liners, the upper main bearings, and the camshaft timing chain assembly. Oil return passages are cast into the side of the cylinder case to provide proper oil drain back to the oil pan. The crankcase bolts to the bottom of the cylinder case and incorporates integral main bearing caps. The case is fully supported by an aluminum lower crankcase. Dovetailing between the cast iron caps and the lower crankcase prevents separation of the assembly under the intense loads the LT-5 is capable of generating. The design helps ensure that the cylinder bores remain perfectly straight. In an unusual design, the lower crankcase assembly extends the structure below the center line of the crankshaft. This results in maximum structural rigidity. The design stiffens the block and simplifies sealing by eliminating the usual curved front and rear seals. The engine block, lower crankcase assembly, and the oil sump have cast-in oil drainback passages on the outside of the cylinders. All of the upper engine oil drains back through these passages, which enter the sump below the oil level. That minimizes the amount of drag from oil splash, which the rotating crankshaft is exposed to, as well as provides good sound deadening properties. Note that the engine timing indicator plate has no service value. Servicing the crankshaft torsional damper begins with the removal of the serpentine belt. Remove the bolt and washer retaining the damper to the crankshaft. Use the puller to remove the damper. Remove the key from the crankshaft. If the damper is being replaced, you must install new balance weights in the same hole locations with respect to the keyway as the old damper. Apply Loctite 262 to the bolt threads and tighten the bolt to 200 Newton meters. The cast iron camshafts are driven by a small block type primary chain that drives an idler located in front of a roller chain sprocket on a common hub. The camshaft sprockets are driven by two duplex secondary timing chains routed through the front of the heads. Primary chain tension is maintained by a single guide positioned between the crankshaft sprocket and the idler sprocket. Tension in the secondary chains is maintained by hydraulic chain tensioners, one per bank. Because the idler sprocket is offset from the crankshaft center line, the left side secondary chain is longer than the right side chain. Force is applied to the chains through a pivot guide at each tensioner. Two fixed guides, one next to each pivot guide, and two top guides, one in each camshaft cover, provide damping and prevent excessive chain travel or noise. There are differences between each of the four camshafts in the LT-5 engine. Bands have been machined into each camshaft for identification purposes. The right exhaust camshaft has one raised band only. The right intake has one flat band only. The left intake camshaft has one flat band and one raised band, and the left exhaust camshaft has two raised bands. There are additional methods of identifying the different camshafts. The reluctor for the camshaft sensor is located on the left exhaust camshaft. Another way is to look for either an LH or RH, which is cast into the camshaft. Finally, you can compare the profiles of the cam lobes for the primary and secondary valves. If one lobe is different from the other, the camshaft is an intake. If they are the same, the camshaft is an exhaust. Hydraulic lifters maintain zero lash between camshaft lobes and the valve stems. Scallops in the lower cam bearing halves are designed to spray oil onto the followers. To remove the left-hand camshaft cover, drain the coolant below the level of the coolant outlet pipes. Then remove the coolant pipes. When camshafts are to be removed from the head, always remove the exhaust first, then the intake. Servicing the camshafts, lifters, and valve assemblies of an LT-5 requires several procedures not normally performed on GM engines. If all four camshafts must be serviced, you should remove the engine from the car. In a few minutes, we'll discuss the procedures for servicing just one pair of camshafts, which can be performed without removing the engine. The camshaft removal procedure begins with removal of the electrical connector from the crankshaft ignition timing sensor. The sensor can now be removed from the cylinder case. The crankshaft must be in a specific position when the camshafts are reinstalled. This crankshaft positioning tool has a spring-loaded plunger designed to assure the crankshaft is at the desired location. The tool can be in three positions. In its outermost position, the plunger is resting on the surface of the disc. Rotate the crankshaft until the tool plunger snaps into a notch in the crankshaft timing disc. For the crankshaft to be in the correct position, however, the plunger must be in the one deep notch in the disc. If the plunger drops into a shallow notch, as shown here, the tip of the plunger will stand up from the tool head. Pull the plunger out of the notch and continue to rotate the crankshaft until the plunger snaps into the deepest notch. Notice that the plunger is now flush with the head of the tool. With the plunger seated in the deepest notch, the crankshaft is at the required 51° before top dead center position. It is possible for the crankshaft to be 360 degrees out of time with relation to the camshafts. That condition will be determined when the camshaft timing procedure is performed. One way to bring the crankshaft to its approximate location is to check the mark on the torsional damper. If it is at the 1 o'clock position, the deep notch should be close to alignment for the tool. Precise holes have been machined into the camshaft retainers and the camshaft. The camshafts have oil holes machined into them. These holes align with the timing holes and can be used to bring the camshafts close to the desired position when they are being installed. Remove the secondary timing chain tensioner assembly. Once they're removed, the tensioners cannot be reused. They must be replaced with new assemblies. There is one tensioner for each of the timing chains. Now you can remove the fasteners retaining the camshaft sprockets. To prevent the camshafts from turning and thus exerting pressure on the crankshaft positioning tool, use a wrench on the rear camshaft hex when removing the sprocket bolts. Now remove the vernier timing plate and the timing pin. Take care not to drop the pin or vernier plate into the head. Gently turn the camshaft at the rear hex and remove the timing pins. Unfasten the camshaft retainers. Evenly release the tension from each bolt. The camshaft and sprocket can now be removed. Install the special tool to retain the loop in the secondary chains. Repeat the procedure for the second camshaft. Move on to the other bank and remove the second pair of camshafts. When the lifters are removed, retain them in their proper order so each can be returned to its original bore. If you're installing a new camshaft, always install new lifters. The correct procedure for installing the camshaft begins with lubricating the bearing journals and lifters with a small amount of clean engine oil. Do not allow the lubricant to contact the cam cover surface, as it will prevent the anaerobic gasket material from curing properly. Always install the intake camshaft first. Engage the sprocket onto the secondary timing chain while removing the tool. Slide the camshaft into the sprocket and rotate it so the timing holes are in the up position. Now lubricate the cam lobes. When the camshaft is in its desired neutral position with nominal timing at 114 degrees plus or minus 2 degrees, and with the crankshaft at its correct position, the pistons will be out of the way and the cam lobes will not be pressing down on the valves. The front camshaft retainers have machined holes that mate with locator pins in the camshaft housing. The camshaft retainers on the right bank are fastened between cylinders 2 and 4 and 6 and 8. On the left bank, they're fastened between cylinders 1 and 3 and 5 and 7. Evenly tighten the retainer fasteners to specification. Rotate the camshaft slightly until the timing holes are lined up, then install the timing pin tools. Install the vernier timing plates. Loosely fasten the bolts. To assure that the chain is not kinked, press on the blade through the tensioner hole. Now you must install the camshaft tensioner tool. This tool presses on the tensioner blade. Rotate the tool handle by hand only. Continue tightening the tool until all slack is removed from the chain. Do not over-tighten the tool. Now you can complete the installation of the vernier timing plates. Note that the holes are not symmetrical with relation to the flat in the D-drive center hole. If you are unable to locate a timing pin through a hole in the plate, turning the plate over will reposition the holes. We'll demonstrate how this works in a moment. Remove the camshaft bolt. Position the vernier plate and rotate it clockwise to take up the slack in the D-drive center hole. Grasp the timing pin by the flat end and attempt to slide the pin through the plate into the sprocket. If you're unable to find holes that align, turn the vernier over and try again. If the pin doesn't slide easily into place, you can tap it gently with a mallet. Note that the pin will come up against the shoulder of the camshaft when it is fully installed. Turn the pin so that the flat faces the center of the camshaft. The camshaft bolt washer indexes with this flat to hold the pin in position. Then tighten the sprocket bolts. Now you should check the engine for correct timing. Remove all of the camshaft timing pins and the crankshaft positioning tool. Install the temporary camshaft bearing tools onto all 4 camshafts. These bearings support the camshaft in the same manner as the camshaft cover. There are 4 temporary bearings per camshaft. They must be installed in the locations shown here. Rotate the engine 720 degrees and reinstall the crankshaft positioning tool. Reinsert the camshaft pins to recheck the timing. The fit may be a little tight. This procedure is necessary to assure that the timing is set correctly. If the timing is correct, you can now complete the camshaft installation procedure. After installing the exhaust camshaft, degrease the threads in the front of the camshaft. Remove the camshaft bolt. Degrease the bolt. Note that this should be a new bolt. Do not reuse the old one. Lubricate the washer. Apply Loctite 262 to the bolt and install it. The torque angle specification on the sprocket bolts is critical. While holding the camshaft at the rear hex, use a torque angle meter to tighten these bolts to 25 Newton meters. Then turn the bolts an additional 80 to 85 degrees. Remove the tensioner tool and prepare to install a new tensioner. The hole in the tensioner should face the top of the engine. Install a new O-ring. Torque the bolts to specification. Remove the taper plug. Then gently tap the end of the tensioner with a blunt tool to release the internal spring. The tool should be the largest possible to fit into the hole to prevent damaging the check ball in the end of the piston. Finally, apply Loctite 565 to the taper plug and tighten it. Always install a new tensioner which is in its compressed state. The tensioner removed from the engine will be expanded and cannot be properly retracted. You can determine if the tensioner is improperly installed in the right bank by pressing on the end. If the chain moves, you must remove the tensioner and rotate the fork end so it correctly straddles the chain guide. This procedure will not work on the left bank, as the weight of the guide will eliminate any slack in the chain. Remove the camshaft timing pins, the crankshaft positioning tools, and the camshaft bearing tools. Finish the job by repeating the camshaft installation procedure on the second bank. If you find that the holes in the vernier and sprocket lie in a position where you can't reach them with the pin, even when you've turned over the vernier plate, you must follow a special procedure. Begin by marking the holes in the vernier plate and sprocket which are aligned. Next, install the camshaft sprocket bolt and tighten it to 25 to 30 pounds-feet. Then remove all of the camshaft timing pins and the crankshaft positioning tool. Rotate the engine slightly until you can access the vernier and sprocket holes. Now take a small piece of cardboard, a matchbook cover will do, and insert it between the camshaft bearing tool and the camshaft and tighten the tool in place. The objective is to keep the camshaft from rotating when the sprocket bolt is removed. Remove the bolt and washer. Insert the timing pin through the vernier plate, then reinstall the bolt and washer. The next step is to remove the cardboard, then retighten the bolts. Gently rotate the engine backward so the camshaft timing hole goes past the retainer hole. Then rotate the engine forward to align the holes. This process removes any backlash. Install the camshaft timing pins and the crankshaft positioning tool. Complete the timing process following the procedures we just described. Under certain circumstances, you may have to time only one pair of camshafts. This could occur, for example, if you are replacing a noisy lifter or installing a new camshaft. For the purpose of this video presentation, the electrical harness has been removed. It is not necessary to remove the harness when performing the procedure. Also, this procedure can be performed without removing the engine from the vehicle. Begin by rotating the engine so the mark on the torsional damper is positioned at 1 o'clock. The temporary camshaft bearing tools should be installed. Inspect the camshaft retainers to see if the timing holes align. If they are, the engine is timed correctly and will remain so when the camshaft is reinstalled. If the timing holes do not align, the engine is 360 degrees out of time and must be rotated an additional 360 degrees. Once this has been done, install the crankshaft positioning tool and the camshaft timing tools. Now, remove the chain tensioner. Remove the camshaft timing pin, the camshaft sprocket bolt and washer, the vernier plate and pin. Loosen the camshaft retainers. If they are tight, wrap them lightly with a mallet. Remove the camshaft, leaving the sprocket in place. Use the chain loop retainer tool to keep the chain from falling into the head. After performing the required service, reinstall the camshaft, orienting the timing holes in the upward position. Install the retainers. Rotate the camshaft and install the timing pins. Install the camshaft chain tensioner tool. Next, install the vernier plate and timing pin and the sprocket washer and bolt. To verify that the timing is still correct, remove the camshaft timing pins and the crankshaft positioning tool. The temporary camshaft bearings should be in place. Rotate the engine 720 degrees, then reinstall the camshaft timing pins. If the holes are aligned, the engine will be timed properly. Now you can degrease the camshaft sprocket threads and the threads of a new bolt. Lubricate the washer. Apply Loctite 262 to the threads and torque the bolt to specification. Complete the procedure by installing the chain tensioner.
End Part 8. You should now prepare to take the next part of the test for this course. If you are unsure of the answer, you may stop the tape to think about the question, review the course book, or rewind the tape and review it before answering. Test Part 8. Start this part of the test at line number 24. Question number 24. When the camshafts are being removed from the head of an LT-5, A, the exhaust camshaft should be removed first. B, the intake camshaft should be removed first. C, mark their positions for easier timing during the reinstallation. Or D, none of the above. Question number 25. The correct position of a camshaft being installed into the head of an LT-5 is A, determined by the vernier plate, B, determined by the chain drive, C, neutral, or D, all of the above. Question number 26. The hole in the camshaft chain tensioner piston on an LT-5 engine, A, should face the top of the engine. B, should be sealed before installation. C, is used to adjust spring tension. Or D, all of the above. Question number 27. If a new camshaft is being installed into the head of an LT-5, A, install new lifters. B, lubricate the cam lobes. C, lubricate the bearing journals. Or D, all of the above.
The cylinder head is retained with 10 14-millimeter bolts, which must be removed for cylinder head service. The exhaust manifold must be disconnected but not necessarily removed from the vehicle to perform service on the cylinder head. After disconnecting the vacuum hose from the secondary port throttle valve actuator, remove the access plug from the front of the head. Disconnect the top bolt retaining the secondary timing chain fixed guide. The bolts retaining the cylinder head, the head and its gasket can now be removed. Unfasten the linkage heat shield. Remove the spark plugs and disassemble the secondary port throttle actuator and linkage assembly, as well as the shaft lever, actuator bracket, and throttle valve. Remove the secondary port throttle valve. Disassemble the bearing and shaft assembly. Remove the bearing from the shaft. Remove the throttle valve shaft seal from the cylinder head. The correct orientation of the throttle valves is critical to the LT-5's performance. Begin the procedure by installing the valve shaft seal, then install the bearing onto the shaft. Now the bearing and shaft can be installed into the cylinder head. Stake the bearing in 3 places with a center punch to prevent walkout and port throttle valve binding. Install the actuator bracket. Install the shaft lever and snug up the nuts. Install the throttle valve onto the shaft. Apply Loctite 262 to the screws and finger tighten them into the shaft. Use the special tool to center the valve in place. Then tighten the throttle valve screws. Rotate the valve 360 degrees and check for any binding. The gap between the valve and the bore should be 0.25 to 0.35 millimeters. Now install the link assembly to the actuator. Apply vacuum to the actuator to simulate port throttle valve operation, or open the valves manually. Hold the throttle valves in a vertical position. This tool assures that the valves are properly aligned and centered. Tighten each valve shaft lever nut to specification. Disassemble the valve keys. Remove the upper retainer, outer spring, and inner spring. The valve can now be removed from the cylinder head. Remove the intake and exhaust valve guide seals and remove the lower retainer. To reinstall the valve, install the lower retainer and the valve guide seals. Lubricate the valve with engine oil, then install the valve, inner and outer springs, and the upper retainer. Install the valve keys. Strike the valve stem tip with a mallet to seat the keys. The Nickel-plated forged aluminum cylinder liners are slip-fitted into the cylinder case and sealed with Loctite 565, a special heat-resistant sealant. If the liners are replaced, all of the old sealant material must be completely removed. Coolant is circulated around the upper half of each liner, creating the wet liner name. The liners have protecting ribs at the top to serve as a flame guard and a pilot for the head gasket. The oil pan carries a fabricated sheet metal windage tray and surge baffle. It surrounds the cast aluminum oil pickup, which is bolted to the bottom of the oil pan. The pickup seals to the crankcase with a rubber O-ring where a cast passage directs oil to a crankshaft-driven gerotor design oil pump. Make certain the O-ring is properly positioned when the oil pan is installed. When reinstalling the oil pan, apply Loctite 242 to the oil pan bolts before assembly. After rotating the crankshaft until the piston is at the bottom of its stroke, remove the connecting rod cap and bearings. Mark the side of the rod and cap with the cylinder number to assure a matched reassembly of the rod and cap. The piston rod assembly can now be pulled out of the liner. The rear seal housing should now be removed. Remove the crankshaft sprocket using a puller if required. Next, remove the oil pump seal seat. Now, the oil pump assembly must be removed. To remove the lower crankcase, unfasten the bolts at the main bearing journals. Remove the crankcase and the crankshaft from the cylinder case. Remove the main bearings from the crankcase and cylinder case. Carefully remove the cylinder liners from the cylinder case. Clean all of the sealer deposits from all surfaces. The connecting rods have a center-to-center length of 5.74 inches. The caps are pinned for precision alignment. Special screws hold the caps in place. The cap screws work only in tension. Both the upper and lower connecting rod bearings are identical and are reusable. Locator tangs position them in place. The lightweight aluminum pistons are permanent mold castings. They are contoured inside and out with thin sections at the skirt and pin boss. The heads are concave. Forged steel, full-floating wrist pins are retained by snap rings. 2 matched sets of pistons and liners are used and are labeled A or B. A single engine can have any combination of A or B pistons and liners, but pistons must be matched with liners marked with the same letter designation. The piston, rings, pin, and cylinder liner are all replaced as an assembly. The pistons are equipped with Getz upper and lower compression rings and oil control rings. On assembly, the ring should be positioned with gaps 120 degrees apart. The top compression ring should be installed with the chamfer facing downward. The second compression ring has no chamfer and should be installed with the manufacturing mark facing upward. The rods must be installed onto the pistons so the arrow on the piston is facing the front of the engine, and the chamfer on the journal end of the rod is facing the crankshaft counterweight. This means the rod chamfers will face the front on the left bank of pistons and will face the rear on the right bank. The piston pin retaining rings should be installed with the gap facing the top of the piston. Measure the liner standout height on 2 sides. The average of the 2 distances from the cylinder case deck to the lower ridge at the top of the liner should be between 1/1000th and 3/1000th of an inch. Make certain the ridge on the liner is above the cylinder case deck. Now, remove the liner. Apply about a 1/2-inch band of Loctite 565 around the circumference of the liner, about 1 inch from the bottom edge of the liner. The liner flats should be positioned 90 degrees to the crankshaft axis. The flats of adjacent liners should be parallel so that a small gap exists between them. Be certain there is an equal distance between the flats of the liners. Install the special tool to seat the liners and hold them in place until the head is installed. To install a piston into its liner, slip the top compression ring into the cylinder bore. Use a ring compressor tool to fit the piston into the liner.
End Part 9. You should now prepare to take the next part of the test for this course. If you are unsure of the answer, you may stop the tape to think about the question, review the course book, or rewind the tape and review it before answering. Test Part 9. Start this part of the test at line number 28. Question number 28. Pistons and liners in the LT-5 are A, labeled A and B. B, interchangeable regardless of labeling. C, replaced as individual components. Or D, restricted to A or B in a single engine. Question number 29. The relationship of the cylinder liner flats to the crankshaft axis on an LT-5 should be A, 180 degrees, B, 120 degrees, C, 90 degrees, or D, 45 degrees. Question number 30. Connecting rod caps in the LT-5 are held in place by A, locator tangs, B, alignment pins, C, Loctite 565, or D, screws. Question number 31. The chamfer on the journal end of an LT-5 piston rod, A, faces the arrow on the piston head, B, faces the crankshaft counterweight, C, must be lubricated before reinstallation, or D, all of the above.
The forged steel cross-drilled crankshaft is internally balanced and designed for high strength and durability. Notice that there are no grooves or oil holes in the main bearing shells. There are no oil galleries in the block, which would normally feed the mains. Oil is fed through the front of the crankshaft through a hole in the center to provide lubrication for the main bearings and connecting rod bearings. Threaded access plugs are at the center of each rod journal for machining and cleanup purposes. Elimination of the center groove improves load distribution and eliminates two bearing edges. Twin flats on the crankshaft drive the oil pump. The crankshaft ignition timing disc has 9 notches machined into it, including one that is deeper than the rest. This disc provides exact crankshaft position information to the ECM. The crankshaft, torsional damper, and flywheel are dynamically balanced as a unit before final assembly to ensure maximum smoothness and longevity. All reciprocating parts are balanced and assembled in matched sets. LT-5 crankshaft service includes a number of procedures not normally performed on GM engines. These procedures allow all of the internal oil passages in the crankshaft to be blown out with compressed air. The taper plug can be removed. The clutch pilot bearing can also be removed. Then remove the rear cup plug by tapping it gently on one side with a screwdriver to pivot it so it can be removed with needle nose pliers. Protect the crankshaft bearing journals by covering them with tape. Then insert a suitable tool to tap out the remaining cup plugs. It's critical that the rear cup plug be installed at the correct depth to prevent serious oil leaks. To accomplish this, first apply Loctite 620 to the plug, then insert the plug into the crankshaft. Attach the clutch pilot bearing to the installation tool and drive it into place. The clutch pilot bearing installer is the only approved tool for this procedure, as it will not reposition the cup plug. Do not use any other tools or procedures to install the clutch bearing or cup plugs. Now the remaining cup plugs can be installed. Finally, apply Loctite 565 to the taper plugs and tighten them in place. Notice that the rear main bearing is wider than the others and has a locator tang. Bearing number 3, the thrust bearing, is also a specific dimension. Bearings 1, 2, and 4 are all identical. If you are reusing the bearings, they must be reinstalled in their same locations. The lower half of the bearings, except for number 1 bearing, generally will show greater wear and abrasion. If the lower half or the upper half shows evidence of wear or damage, both halves should be replaced. When reinstalling the main bearings, always use new bolts and carefully tighten them in sequence to their proper torque angle specification. Notice that bearing bolts 1, 3, and 5 have a different specification than bolts 2 and 4.
End Part 10. Before answering the last video test questions, please complete the portion of the student attendance and test form that identifies you and your dealership. If this portion of the answer sheet is not completed correctly, you and your dealership will not receive credit or certification for this course. Begin by placing the student attendance and test form in front of you so that the clipped corner is now in the upper right. Print your last name in block 1. Located in the upper left-hand corner, putting only one letter in each box. Print your first and middle initials in block 2. Print the name of your dealership in block 3. Your dealership city in block 4 and state in block 5. Be sure to use the official U.S. Postal Service abbreviation for your dealership state. Print your Social Security number in block 6. Enter your dealer code in the space provided. Print today's date in block 8. Return to block 1 in the upper left-hand corner of the form. Below each letter of your name is an alphabet. Fill in the circle with the letter that corresponds to the letter of your name at the top of the column. Follow the same procedure for the numbers of your Social Security number in block 6. Today's date in block 8, and your dealer code in the space provided. You should now prepare to take the final part of the video test for this course. Test Part 10. Start this part of the test at line number 32. Question number 32. The crankshaft, torsional damper, and flywheel on an LT-5, A, have no serviceable parts. B, are made of an aluminum alloy. C, are balanced as a unit before final assembly. Or D, must be aligned for proper cam timing. Question number 33. The crankshaft on an LT-5, A, has removable taper plugs. B, has replaceable cup plugs. C, can have the internal oil passages blown out. Or D, all of the above. Question number 34. The thrust bearing on an LT-5 is main bearing number A, 1, B, 2, C, 3, or D, 5. You have now completed the video portion of the test. The course book accompanying this videotape contains the final part of the test. Once you have completed the test, you may wish to make a photocopy of it for your records. After photocopying, place the student attendance and test form in the pre-addressed envelope. No postage is needed. Remember to complete the questions in the back of the course book before mailing the test form to CPT headquarters. Good luck!